and our Q&A moderators will respond as much as possible during the presentation. After the presentation, there will also be a live Q&A where we respond to selected questions. Assisting in today's Q&A will be Tim Hunt, Senior Product Manager for S3. Presenting today is Guy Farber, Business Development Manager responsible for AWS storage services. His focus is on helping customers optimize their data storage infrastructure by leveraging AWS's cloud storage services, collecting customer feedback for S3 and Glacier product development, and leveraging partners to complement AWS storage solutions. Prior to AWS, Guy filled several sales and systems engineering roles with leading data storage and networking manufacturers. Thank you for joining us today, Guy.
Thank you, Colin. And hi, everyone. Thanks for joining the webinar. The webinar today is a 300-level session, so it's targeted at sysadmins and developers who are familiar with storage technologies and spend some time with Amazon S3. Today, I'm going to give you an update on the new features we introduced this year, including very recent ones, and show you how you can leverage them to simplify your application architecture, lower your cost, increase availability, as well as improve your security. So we're going to talk about several topics. We're going to start with security, with server-side encryption, with our key management service. We'll then move on to data protection with lifecycle management for versioning and cover cross-region replication. And then we'll talk about a feature that significantly simplifies your management and security posture with VPC private endpoints. And then finally cover the recent announcement where we added S3 delete event notifications, CloudWatch metrics for S3 storage, and as well as increased the bucket limit per account. So let's start with encryption. S3 provides a lot of flexibility when it comes to securing your data. There are two main approaches that we provide. One is client-side, where you, the customer, handles data encryption, and server-side, where you offload it to AWS. And today I want to focus on the server side and some of the improvements we've done on that front. So if you prefer that AWS encrypts the data for you, the simplest way is to use server-side encryption, or SSE, where you hand over key management to S3. S3 encrypts every object with a unique key and encrypts those with a master key that gets regularly rotated. And you request encryption as part of a put operation. We manage the key and encrypt the data at rest. So basically, this is the option that where you cede the most control and offload basically both encryption and key management to the service, to S3. If you want to gain more control and manage your own keys, you can do that using SSE with customer managed keys. This is where basically you're going to be managing the keys and providing them to S3 as part of a put or get request. S3 will use the keys that you provide to encrypt or decrypt the data, and it will eliminate those keys right after the encryption or decryption operation. So it's very important that you store those keys in a very durable store, but you gain, again, a higher level of control managing your own keys, and S3 still encrypts the data for you. Finally, you can use Amazon's key management service, which we announced at reInvent last year. It enables you to centrally and securely manage master encryption keys. And what's really nice about it from an S3 perspective is it integrates with S3. It allows you to be in control of key creation, removal, rotation, and audit, but offloads the infrastructure management to AWS. So let's dive a little bit deeper into how that works, specifically server-side encryption using KMS. So AWS Key Management Service, again, is a managed service that makes it easy for you to create and control the encryption keys used to encrypt the data. And it uses specialized hardware security modules to protect the security of your keys. S3 is one of the services that are integrated with KMS to provide envelope key encryption. So I want to walk you through what happens during a secure put or get process. So let's start with a put. S3 requests a plain text data key and a copy of the key encrypted by using the specified customer managed master key. That's the key you created in KMS. The KMS creates and sends both the plain text key and the encrypted data key to S3. S3 then encrypts the data using the data key and removes the plain text key from memory as soon as possible after use. And then S3 stores the encrypted data key as metadata with the encrypted data. At this stage, after it completed encrypting the data and it doesn't have the plain text encryption key, S3 itself doesn't have visibility into the data. During a GET operation, S3 sends the encrypted data key to the AWS KMS, which has the customer envelope key or master key. KMS decrypts the data key using the appropriate master key and sends the plain text key back to S3. Now S3 can use that plain text key to decrypt the ciphertext. After decrypting, it automatically removes the plain text data key from memory as soon as possible, and the operation has been completed. So basically everything, you have one point of control with the KMS, and S3 outside of the encryption and decryption operations doesn't contain the encryption keys. Let's move on and talk a little bit about data protection, and specifically how lifecycle policies simplify the use of an S3 feature called versioning, which is very powerful. So before we dive into versioning, I want to talk about how S3 physically protects data. When you put an object into S3, S3 automatically replicates the data, the object, into 3 different fault-isolated facilities before it acknowledges back that the put operation was successful. This allows us to recover from a complete facility failure and concurrently additional device failures in the other facilities. If we do encounter a failure, we automatically recover the data under the covers behind the scenes without any involvement from the customers. So it basically has built-in DR, and the durability metric that we derive from that is 11 nines of durability. So it's a very extreme level of physical protection. But that only protects you from physical issues. What happens if you have a human error or a data corruption issue? This is where you need logical protection. And so versioning then comes in to augment S3's extreme durability and high availability with logical data protection. Once you turn on versioning, which you can turn on at the bucket level, S3 will keep a version of all changed objects to protect you from human error or data corruption. And whenever you rewrite an object, it'll keep the previous object and give it a version ID. In case you need to go back, you can either read directly the version object, or you can take the version object and copy it over the new one, basically promoting it to be the primary version of the object. So again, you can turn versioning on for a bucket in the management console. It's really easy, and as soon as you turn it on, you're protected. A lot of customers, previous to our launch of lifecycle for versioning last year, were very hesitant to adopt versioning. And the reason was that they were concerned about not being able to limit the number of versions that they keep and the capacity associated with those versions. So that was why it was so important for us to introduce the ability to apply lifecycle policies to versioning, which allows you to limit the number of versions and for how long you're keeping them by applying an expiration policy to these objects. So let's see how you can optimize your storage by tiering on AWS and leveraging these lifecycle policies. S3 is inexpensive, but we also give you the flexibility of using 2 less expensive options. The first is called reduced redundancy storage, which is a less durable storage tier for a lower cost. It can be accessed in real time like S3 standard, but it's got 4 nines of durability versus 11 for standard, and it's roughly 20% less expensive than S3 standard. This is a good choice for reproducible or temporary data sets. And the second choice you can see in the diagram here is Glacier. Glacier is optimized for infrequently accessed data. It's usually kept for compliance or reference purposes, and it's priced at $0.01 per gig per month, which is close to a third of what S3 standard costs. So you want to take advantage of this storage class wherever possible. The thing to keep in mind with Glacier, for those of you who are not familiar, is it was designed for infrequently accessed data. So the retrieval time to first byte is 3 to 5 hours, and that is your trade-off. So with lifecycle policy support for versioning, you can now not only expire versions, delete them automatically after a certain period of time, you can also migrate them to be stored more economically on Glacier and sort of create a tiered version set. So for example, if you were on the fence regarding keeping older versions, for example, the ones older than a month, at a cost of 3 cents per gig per month, the cost of S3, it might be worth it for you to keep them on Glacier at $0.01 per gig per month. We definitely see a trend of customers retaining more data for longer periods of time as we cut storage pricing and give you more economical options. So I want to give you an example of a lifecycle policy, how it looks like, which, as I mentioned, can be applied to both primary and older versions of an object. So here in the example I have, we're going to take all the objects that start with the prefix logs /, which in this example I'm going to be storing all my logs in. These logs are then rarely accessed after 30 days. So I'm going to transition all these objects to Glacier automatically after 30 days by applying this policy. And at the moment they move to Glacier, I'm going to start paying a third of the cost that I was paying before. But then I don't also want to worry about what happens when these logs are becoming completely useless to me. I want to automatically delete them. And so the second part of this policy automatically expires or deletes these logs after a year since creation on S3. So it's pretty powerful stuff. You don't need to manage your data anymore. You just set these policies and they'll automatically move the data between tiers as well as clean them up. Cross-region replication is another tool you should probably be using for data protection. It's very powerful. So S3 and Glacier, as I mentioned before, provide 11 nines of durability pretty much out of the box as soon as you start using them. But even though they provide that extreme measure of durability out of a single AWS region, some of our customers were asking us to automate replication of objects between AWS regions to help them achieve their compliance objectives, because sometimes for compliance purposes, organizations need hundreds of miles of distance between different copies of very critical data sets. Other use cases that people have been asking us for is being able to copy data remotely to get it closer to their customers to achieve lower latency. And also an interesting use case is to enhance access security, which I'm going to discuss in a few minutes. So S3 users can now configure automatic replication of newly created objects with a few clicks of the AWS console. This is supported between any two regions, both at the bucket and a key name prefix granularity. What that means is that we don't force you to replicate whole buckets. You can sort of segment your bucket into separate prefixes, some that you want to replicate and some that you don't want to replicate, and you have the granularity to control that replication. And like I mentioned before, many customers told us that they plan to use this feature to enhance their access security by replicating data between buckets and then assigning a different set of access credentials to one of the copies, so they have separation of access between two independent copies of the data. And that's pretty powerful stuff. Few more details around cross-region replication or things you should be aware of. So one of the things we require with CRR, with cross-region replication, is for versioning to be turned on. And the The reason we do that is because we want to avoid a situation where you replicate hard deletes. And what I mean by hard deletes is deletes that are not protected by versioning. So you accidentally delete an object at the source, it gets replicated to the destination, and then basically you lost your data. If versioning is turned on, that can never happen because you can always go back to one of the previous versions and pull it back. So versioning is required to be turned on for cross-region replication to work. You can definitely leverage lifecycle rules with cross-region replication. The way this works is you can apply a policy on the destination bucket, and what you can achieve with that is instead of just using S3 standard on both source and destination and paying the standard rate on both, you can replicate from S3 standard to Glacier, from S3 standard to another S3 standard bucket on the destination and apply a policy that automatically moves those objects upon successful replication into Glacier. And then your cost goes down significantly to the cost of one copy on S3 standard and one on Glacier. If you want your application to determine the replication status of an object, you can easily use the head operation as on the source object, and you can see whether it was replicated or not. Most objects are going to be replicated within minutes, but for very large objects, that could take a little bit longer. Something that might be a little bit less intuitive and is important to note, at this time we only support region-to-region bucket replication. So that means that you cannot replicate between buckets within the same region. We're aware that this functionality is important and we're evaluating that. But again, at this time, you can only replicate between buckets that reside in different regions. And then finally, new object replication only applies to new objects. So when you turn on cross-region replication, from that point onwards, we will take every new object that's written to the source bucket and replicate it to the destination bucket. We've heard from customers that it's fairly easy to use our copy API and our copy function and our CLI to replicate the existing data. But again, we're evaluating the possibility of adding this functionality so you don't have to worry about it. Another highly requested feature we recently released a few months ago is virtual private endpoints for S3, or what we call, in short, VPCE. Before VPCE, and you can kind of see it on the diagram on the left, customers using S3 and other regional services from our compute service, EC2, were accessing them as external internet service. So S3 was sort of an external internet service to EC2. This approach, again, as you can see on the diagram on the left-hand side, has the disadvantage of requiring customers to use internet gateways to exit the EC2 network. In addition, if you were using instances that were leveraging private IP addresses, it also required you to set up NAT instances with all the associated management, scaling, and high availability that are needed to support that NAT functionality. VPCE does away with all of this complexity, and it also improves your security by guaranteeing that access to S3 from the EC2 network within the same AWS region will always go over the internal Amazon network. Again, I want to emphasize this applies only when EC2 and S3 are within the same AWS region. Now, if you use Virtual Private Cloud, or VPC, our EC2 service that allows you to have your own isolated network within EC2, you can create a private S3 endpoint for that specific VPC. So you basically bring S3 access into your VPC. You can see on the diagram on the right-hand side the much simpler traffic flow. It's much easier to configure and manage because you no longer need internet gateways, IGWs, or NAT. It's more secure because you're guaranteed to stay within the AWS network, and it could potentially actually be more performant as well if the NAT instances you had to maintain before were becoming a performance bottleneck. or adding latency to the process, since they're no longer needed. You can create multiple endpoints within a single VPC, each with a different S3 security access policy for fine-grained control per application or project. And finally, this is more than just a feature for S3. It's an infrastructure innovation that will allow us to add additional private service endpoints in the future. S3 was the most highly requested by customers, so we're starting over there. So I want to walk you through the creation of a VPC endpoint. You can create and configure VPC endpoints using the AWS Management Console, which we're going to show you in the next few slides. But you can also use our command line interface, the tools for Windows PowerShell, as well as the VPC API. So let's start by opening up the VPC dashboard. There, you're going to be selecting the desired region because an endpoint lives within an AWS region. And then you locate the endpoints item in the navigation bar on the left-hand side of the screen, and you click it. In the next step, if you've already created some VPC endpoints, they would appear on this list at the bottom. And in this example, we don't have any, so we're just going to go ahead and create a new endpoint. After you choose to create an endpoint, you need to choose the desired VPC to put that endpoint inside. You can also see which AWS region you previously selected, so just to validate that before you continue. And you have an opportunity to customize the access policy. It's important to note that by default, a VPC endpoint can access any S3 bucket. The access policy allows you to deny requests to untrusted S3 buckets, so to limit that access. And you can also use access policies on your S3 buckets to control access from a specific VPC or VPC endpoint. In the final step, you just choose the VPC subnets that will be allowed to access the endpoint, and at that point, you're basically done. I'd like to emphasize the access policy a bit more with an example here. So as you've seen, we not only consider S3 VPCE as a convenience and performance enhancement feature. We also think of this as a security feature. So here in this example, you can see how you can lock down access to your bucket to a specific VPC endpoint or a set of endpoints using S3 bucket policies. S3 bucket policies now support the condition AWS:/source VPE that you can use to restrict access. And in this example, you can see that you can lock down access to your bucket. The bucket name is My Secure Bucket, to a specific VPC endpoint, which in this example is VPCE-123ABC. So we're basically restricting access to everyone, to everything, or every S3 bucket, except that specific one. Similarly, you can prevent your VPC endpoint from making requests to untrusted S3 buckets by using IAM policies. IAM is Amazon's authentication authorization service. IAM policies allow you to manage what buckets a VPC endpoint can access, and by default, a VPC endpoint will have access to any S3 bucket. You can attach an IAM policy to your VPC endpoint using either the API, SDK, or as you've seen, the console. So back at reInvent, we announced S3 notifications on object creation. So basically the way this works is as soon as your application uploads an object to S3, for example, a new high-res photo, S3 will fire off a notification that goes to either SNS, our simple notification service, SQS, our simple queuing service, and from there be picked up by a worker, or Lambda. Lambda, for those of you who are not familiar with it, is a compute service that runs your code in response to events and automatically manages the compute resources for you, making it easy to build applications that respond quickly to new information. It's really the cornerstone of our event-based computing paradigm, and the sort of events we're talking about here are, like I said, the creation of a new object on S3. A few weeks ago, we extended this feature to also include delete operations. So it's no longer just create, it's also delete. And also added the capability to apply filters on an object name's prefix and suffix to create more selective triggers rather than the all or nothing proposition we had before. So before, you either had to get notifications on all newly created objects. Now you can create some naming schemes that will allow you to differentiate which objects on creation or delete you want to notify and which ones not. So some of the benefits that we've seen for S3 notifications, the first is integration. It's a key building block for event-based computing. It enables you to architect applications in a completely new way where blocks of code or workflows are invoked by changes in the data. The second one is speed. If you need processing to occur quickly when new objects arrive, on average, we're going to be able to send these notifications in less than a second. And then finally, previously, if you wanted to build an application that reacts to changes in your data, and again, like the creation of new objects or removal of objects, you had to build and manage a proxy or polling fleet that will keep track of that. This is a very costly proposition and also adds delay to data processing. S3 notifications, like all S3 features, is built on reliable infrastructure and automatically scales as needed. So that's one less thing you need to worry about, and another thing you can just offload to our platform. We've seen some new powerful and interesting use cases from customers adopting this feature since we've launched it at reInvent last year. The first one I want to discuss is transcoding of media files. So imagine that you're developing an application that has user-generated images, like an online store, a dating application, or photo management platform. You can use S3's event notifications in conjunction with Lambda so that when a user uploads a photo, it'll automatically process, using Lambda, a thumbnail and also resized renditions for the different mobile service formats, mobile device formats that you want to support. It'll do that instantly and without provisioning any infrastructure, and then it'll place them back in the appropriate place in the S3 bucket, ready to be served to other users. When the user deletes the image, it'll automatically remove all of these renditions instead of waiting for a cleanup process. And from my conversations with customers, I've seen cleanup processes sometimes take months, and during that time, you're just basically paying for storage or data that you're not really using. Instead of that, you can just automate all of that using notifications in Lambda. Another great use case is updating a data store. Anyone who's been using S3 at a really large scale knows that doing things like list operations across all objects take a very long time, and that it's pretty difficult to query metadata across a whole bucket. So the way to overcome that is to put metadata, associated metadata for these objects in a fast database such as DynamoDB. And what you can do here is that every time a new object gets uploaded into an S3 bucket, it kicks off a Lambda function and then creates an entry in DynamoDB that you can then use to query and index for other purposes. And you can do the same thing with deletes. So again, when an object gets deleted, you can then automatically trigger a function that would remove that entry from the database. There's some great uses in processing of data and logs. This is where you can allow partners with the appropriate set of permissions to upload logs into your own S3 bucket. And then when these logs come into the bucket, you can automatically trigger functions that will process them, as well as when they get deleted, remove them. And then finally, change alerts. Sometimes you just want to notify people for a human to trigger a human-based process. For example, if a critical piece of data gets deleted or gets added, you want people to get a notification on their mobile phone using our simple notification service, SNS. As customers increase their usage of S3, we've heard that getting better insight into S3 capacity usage and performance is becoming critical. So a few weeks ago, we introduced our first set of monitoring metrics. As a first stage, we recently started collecting and presenting capacity usage metrics in CloudWatch. CloudWatch is AWS's centralized monitoring service. And what this allows you is to view S3 metrics in the same application you monitor all of the other AWS services in with the same consistent interface, as well as use CloudWatch functions such as setting alarms when the usage exceeds certain thresholds, and see how these metrics trend over time in graphs. The S3 CloudWatch metrics currently include total bytes for both standard and RRS storage classes, as well as total number of objects for each one of the S3 buckets that you're monitoring. These totals are updated at a daily granularity. You can expect us to add additional metrics over time and to also improve the level of granularity monitored by CloudWatch. And another important scaling feature we introduced a few weeks ago is a method to increase the maximum bucket limit per account. So by default, for those of you who didn't know, each AWS account can only create up to 100 buckets per account. So it's really important to use them wisely. Each one of these buckets is unlimited in capacity, and you can also store as many objects as you wish. And we also allow you within that bucket to organize the data into prefixes, which are sort of like virtual directories. So scalability and organizing the data should not require use of separate buckets. And theoretically, and I've seen customers do it, you can manage tens or hundreds of petabytes out of a single bucket. I've seen some customers assign a bucket per person, per group, or project, which is usually unnecessary. You can use prefixes for that, and you can create access level policies at the prefix level. But there are some use cases when you do need to use more buckets. So again, it shouldn't be for scalability reasons or security. But there are a few situations where we have features that only operate at the bucket level rather than the prefix level. And some examples are storing data across different regions. You know, AWS has 11 regions globally, and we keep expanding. And customers want to leverage our geographical reach. And so because a bucket resides within a region, if you want to store data across multiple regions, you will need multiple buckets or multiple sets of buckets. So that's one example. Another example is tagging. Tagging operates at the bucket level. So if you want to use tagging for billing chargeback purposes, for example, you want to track each department within an organization separately, that will require separate buckets for each tag. And in rare situations, I've also seen customers want to provide the ability to use lifecycle policies per one of their customers. So they basically expose the lifecycle functionality to their customers and allow them to make the decision to transition data from S3 to Glacier. When you have thousands of customers, you can quickly run into our limit of 1,000 lifecycle policies per bucket. And then you scale that by creating multiple buckets. So what do we do, or how do we handle a situation where we need a large number of buckets? To make it easier to handle these situations, we recently introduced the ability to go to the AWS Customer Center and request a bucket increase in the bucket limit increase up to a new limit of 1,000 buckets. If you have a use case that requires more than 1,000 buckets per account, please send me an email or contact your account team and tell us about your use case. We're really interested to hear about it. Another way to overcome the 1,000 bucket limit, it's simply to create multiple AWS accounts, because that limit applies at the account level. And you can create as many AWS accounts as you wish. And then the final enhancement we launched at that announcement a few weeks ago is read after write consistency for the AWS US Standard region. I often run into the question of why US Standard, which is the most popular S3 region, only supports eventual consistency on object creation. So while all the other AWS regions that we've launched afterwards support read after create consistency, so they have a better consistency model. This is mostly due to legacy reasons. S3 is a very mature service, which is a great thing. It's kind of hard to believe, but it's the first AWS service, and it's now 9 years old, which is probably like 70 years old in cloud years. And so US Standard was a first region. The good news is that we've enhanced it now to support read after create consistency, making it on par with all other AWS regions. So you should no longer choose a region based on the consistency model. They all look exactly the same. So now if you put a new object into S3 Standard and immediately try to read it, you'll be able to actually read the object, even whereas before, on really rare occasions, you'd be getting a 404 message. And then you have to deal with that by adding logic to your application. So that's no longer the case, and you don't need to worry about it. So at this point, I want to hand this over to Colin for a few quick announcements, and then we're going to start the Q&A session.